Now, in this chapter, we will discuss pointers. So, actually, these are the pointers which will actually give the power to C programming language as such to do many things. For example, to do pass by reference. So we have seen that pass by reference in array by default, whenever we pass the array as an argument in a function, it is passed by reference, right? But for any other variable, it is not passed by reference, it is just passed by value. Okay, so if you want to make a pass by reference to variable as well, okay, we will make use of pointers, right? If you want to pass a function between function, in the argument also you want to pass the function, right? This is also possible in C programming, and this can be done using pointers. If you want to create and manipulate dynamic data structure, right? So as I am talking about variable length arrays, it it is also possible to expand the size of the array or shrink the size of the array dynamically. Okay, and that can be done using pointers as well. So we will see one of these dynamic data structure, that is linked list, in our C programming course, and rest of the data structures you will see in your DSA course. Okay, so in that also you have to make use of pointers. So it is really a very powerful feature of C programming language. So let's see what actually pointers are. Okay, now pointers are also variables. Okay, but these are different from a normal variable. What is the value that is stored in a normal variable? So when I say x equal to 7, what do we mean by x equal to 7? It means that there is a memory location which is reserved, and the name of this memory location is x, and at this particular location what value is stored? 7 is stored. Okay, this is a normal variable. Now pointers are special variables whose value are not some integer literals or string literals or expressions, but the value of the value that is stored in this variable is actually the memory addresses. Okay, we will not assign any integer, string, character, array to this particular location. If a variable is a pointer variable, then what should be stored at this location? It will allow the storage of memory addresses, right? So when we talk about a variable directly contain a specific value, as in this case, right? So x contain a specific value, that is 7. But a pointer contains a address of a variable that contains a specific value. Okay, so pointers are the variable who will indirectly reference to a value. Okay, so let me just give you a diagrammatic representation, right? So here count is a variable who will store 7. Okay, so the count variable directly refer to a value which is of integer type. Okay, now count pointer, count ptr or count pointer is a variable who is indirectly referring to 7. Okay, so what will get stored at this location? The memory address of count. Okay, the memory address of count will get stored in count pointer. Okay, so we will say that what is count pointer? Count pointer is actually pointing to this memory location, and therefore it is written that pointer indirectly reference a value, whereas a normal variable directly reference a value. Okay, why indirectly? Because whatever written in this, you have to go to that address, and at that address value is stored. Okay, so this is one layer of puzzle you have to solve. So you have to first look at what is stored at this location, then you have to go to that location, there you will get the value. Are you following me?
Yes, ma'am.
Okay, and
Yes, ma'am.
referring to this value, referring value in such a way is called indirection. Okay, This is called indirection. So when we refer to a value through a pointer, then this is called indirection. Okay, this is the indirection operations. Okay, now how we can declare and initialize a pointer variable. So a normal variable is declared in this way. We will put int count. Okay, this is the declaration of a normal variable. Whenever you want to declare a pointer type variable, just put a asterisk sign before the variable name. Okay, so what this line is saying, it is saying that count pointer is a pointer. Okay, count pointer is a pointer to integer. It is a variable which will store memory address of a variable which is of integer type. Okay, so count pointer can store the memory address of a variable which is of integer type. This is what it is saying. Okay, and we call it as count pointer is a pointer to int. Count pointer is a pointer to int, or count pointer points to an object of type int. That object could be anything. Here it is a variable. It could be an array, it could be a function, it could be anything. Okay, but it should be of integer type. Right? So in one line we can define in this way. So this is a simple variable because no asterisk is written. Okay, and this is a pointer variable because there is this asterisk sign. If you want to define two pointer type variable, then what you have to do, asterisk x comma asterisk y. These are two variables, two pointer variables of integer type. Any question in declaring the pointers? Yes, no? Okay. Now, asterisk is applied only to count pointer in the definition. So whenever we use this, so that variable, whenever we use asterisk sign before any variable name, that variable name will become the pointer type variable. Okay, and that variable can refer or store the memory address of a variable or any object that is of that type. Okay, so to prevent the ambiguity, we can declare pointer and non-pointer variable separately. But when once you are very much comfortable with programming, you can write it in this way also. Okay, so there is no problem in this. You can define all the integer type variable into one line. Some of the variable could be pointer variable, just put asterisk before that, and some of the variable are normal variables. Okay. And this is the example I was giving, that if you have to declare two pointer variables, then you have to put two asterisk sign. Okay, don't just put one asterisk sign and write both the variables, right? Two separate asterisk signs you have to put, separated by the comma. Okay, and there is this good programming practice. Just try to put PTR or something after the variable just to make it clear that this is a pointer type variable. Okay, but this is not a mandatory thing, but this is just increase the readability of the programmer. Okay, now how we can initialize and assign value to the pointers. Now this is also an important point. So a pointer may be initialized with three things. It could be either null. Null is a symbolic constant. Null means the variable is pointing nothing. Okay, there is no address stored at this location. So suppose this is a count PTR and I am initializing count PTR with null. So this is the symbol that we will use. Okay, nothing is stored. It is pointing to nothing, right? We can also store 0 to this. So this is the only integer that can be stored. But again, 0 also means that nothing. It is pointing to nothing. Or the memory address is stored. Okay. So either nothing will get stored or a memory address will get stored. But no value, no specific value will be stored at this location. Right? So null is actually a symbolic constant which is defined in many libraries that we are using. It is also included in stdio.h, right? So if you are including stdio.h, then null will work. Okay. Now, initializing a pointer to 0 is equivalent to initializing a pointer to null. But please remember, always null is preferred. Okay. So this I am telling you, from every point of view, like it will not create the confusion, and it is the best practice. And whenever you do a C programming in any of the companies, everybody will use null. Okay. Almost no one is using 0 to initialize the pointer, right? So generally we will use null or the memory address. But yes, 0 can also be given, no error will come. 0 will automatically convert it to a pointer of appropriate type, and then it will get stored. Okay. All right. Now, yes, so please remember to initialize pointers. If you use an uninitialized variable, then there are some unexpected output. And same happens with pointers also. If you will declare the pointer and just use it without initializing it, then you can get some unexpected output. Okay, so please initialize the pointer. If there is nothing to initialize, just initialize it with null. Okay. All right. Now let's see how we can give a memory address to the pointer, right? So and person, we have already seen that this is the address operator. This is a unary operator. When we put double and person sign, this is our AND operator. Okay, logical AND operator. But when we give a single address and person sign, this is the address operator. This is unary operator, means it will take only one operand. And what it will return? It will return the address of that operand. Okay, so we have seen this many times when we say, okay, scanf %d, and then we will say and %x, right? It means whatever user will give us, where to store at the address of x, go to the address of x and then store the value which is given by the user. Okay, so this is the address of operator. So when you want to assign the address of any variable to pointer, what you have to do? So this is the example. I'm initializing y to 5. So y is a variable and 5 is stored in this variable. Y pointer is another variable. Y pointer is another variable. Now this statement is initializing y pointer. Okay, so we are saying y pointer is equal to address of y. Okay, whatever is the address of y, you have to point at that location, you have to store that location. Okay, this is what y pointer is doing. Okay, so this statement assign the address of variable y to pointer variable y ptr. Okay, and then we call it as y pointer point to y. Okay, and this is how we make a diagram of such things. Okay, so this is a pointer variable. This will store a memory address of y. Okay, so let's see a representation. So this is how it looks like. Okay, there is one more, I think, example. So let's see this. Okay, the actual memory, what is happening in the actual memory. So suppose, just an example, the location of y pointer is this, and the location of y variable is this. Okay, so the location, this is the memory address where y is assigned. Okay, this is the memory location which is assigned to y. And when we say y pointer, writing y pointer is equal to address of y, then this address will get copied here. Okay, the value of y pointer will become this address. So when we indirect or when we dereference this pointer, what it will do? So the compiler will go to this location. Okay, it will read this value. Okay, this is the value which is written. The compiler will go to this location, and then whatever value stored at this location will be get returned. Okay, so let's see that example also. This is called indirection operator. So this is also a unary operator, indirection operator. it is commonly referred to as indirection operator or dereferencing operator. Okay, dereferencing word is much more common than indirection. What it will do, it will return the value of the object to which its operand points. Okay, please read this line many times. Dereferencing operator returns the value of the object. Which object? Which is pointed by the operand. Okay, so if I say yptr, okay, yptr is the operand, so it will return the value of the object which is pointed by yptr. Okay, so in our example, yptr is pointing to yptr is pointing to y. So this will return 5. Okay, the 5 value is returned. Okay, so this line will print 5, and this is called dereferencing a pointer. Yes, so I will just wait for some time here, just to make sure that you are getting whatever things has been covered. Any question? Do I repeat anything? See, these are the basics of pointer, and please make it very clear then that lots and lots of mistake happen due to misunderstanding of these concepts. They are a little bit confusing. Okay, I agree. But once once the logic is clear, once the concepts are clear, then it will be very simple. Okay, so till now what we have seen is this. We have seen two operators, right? We have seen n% operator. This is the n% operator. This is the address operator. What it will return? It will return the address of its operand. Address of its operand. Okay, so in this case, who is the operand? Y is the operand. What is the address of the y? It will get returned and stored in yptr. What is asterisk? Asterisk is a unary operator or dereferencing operator. Okay, and what it will do? It will return the value. It will not return the address. It will return the value of the object to which its operand points. Okay, so y pointer is the operand. Y pointer is pointing to y. Okay, so this will return the value of this y. So therefore it is returning 5. Yes, any question? Yes, no.
Ma'am, if we use ampersand y instead of asterisk y ptr, then
So address of yptr. What is the address of yptr?
ampersand y
Yes. What is this? What is address of yptr?
5 ma'am ये 5 lakh
Is it 5 lakh or 6 lakh?
ma'am 5 lakh
5 lakh, right? So this will return. What this will return?
6 lakh
What this will return?
5.
Is this a valid operation?
No ma'am.
No. Okay, so error, because this is not a pointer type variable. So when a variable is a pointer type variable, then only we can use a asterisk sign or this dereferencing operator. Okay, otherwise it will not make any sense. So, writing pointer before y will give you error. Okay, but when we write asterisk in front of y pointer, what it will do? It will give us the value of the object that it's operand pointing to, and y pointer is pointing to this location. So it will give the value that is stored at this location. sorry, not this location, this location, okay, because this is what's stored here.
Ma'am, can we write ampersand y in printf statement?
Yes, yes, we can do that. So just wait for one program to come, okay, and then we will see that what all the operations that we can use. So common error is in dereferencing. Please remember, dereferencing a pointer which is not either initialized or it is pointing to some other location. All the error comes in pointer due to the dereferencing of a pointer. Okay, so please make sure that you properly make use of all this initialization, declaration, address operator, and dereferencing operator. Okay, now we will see one program where your question has been solved. So this is the program. If you remember, for printing address, we will use %p, right? We have seen this previously also. %p is a conversion specifier which will print the address of the memory in hexadecimal format. Okay. So now in the program that we will see, what we will actually do, we will try to print the address of y itself, and then we will try to print the value which is stored at the y pointer. Okay, so just to make it clear that you know how the things will work inside the memory. So in this, what we are doing is this is a very simple program. Int a, this is a normal integer, okay, and this is pointer aptr, so it is a pointer type variable. So aptr points to a integer type object. Okay, now we are initializing a with 7. Okay, so what happened, this is a and 7 will get stored in a, and aptr is again a variable which will store memory address. So which memory address we want to store, we would like to store address of a. Okay, so this is actually pointing to a. Okay, so whatever address of this particular a, that will get stored here. Now let's print all the addresses. So now here we are printing the address of a. If you want to print address of a, what is the operator that I should use?
ampersand.
And %a. Okay, so this we have used to print address of a. Now we have to print the value stored at aptr. Okay, because both should be, the address of a and the value stored at aptr should be
Same.
same. Why same?
Same.
Because of this,
Asterisk sign.
what we are storing at this variable, we are storing a memory address. And what is the address? It is the address of a. Okay, so now we are printing two things, value of aptr and address of a. Okay, so this both things should be same. Now let's see the output. Okay, so what will happen in the memory? In memory at some location, let's say 28f, this is a hexadecimal number. Okay, so at this location, compiler say, okay, please go and make it a and store what, 7, I think 7 at this location. Okay, and then we will make another variable to some other location. Okay, this location is not known to us, but anyways you can print this location also using @aptr. Okay, but we don't bother about this location, whatever is the location. But the most important thing is this particular variable is actually pointing to this location. Okay, so what should get stored at this location, this is the value which should get stored at this location. Okay, so if you see value of aptr and address of a, both are same. Okay, because this address is stored in this location. Okay, so this is one thing, and I hope the doubt is clear now. Now what is the value stored at a?
7.
7, and we already know that how to get it printed. We just have to write A. Okay, so 7 will get printed. Now what is the value of asterisk APTR? Now see, there is a difference between value of APTR and value of asterisk APTR. What this will return?
Value of A.
Value of A. Okay, because it will return the value of the object to which its operand pointing to. And since this operand APTR is pointing to A, so asterisk will return the value of A, which is 7. Okay, so again, the value of A and the value of asterisk APTR both are same. Okay, so if you see the output, both are same. And this is the difference. Okay, so please remember, value of APTR is different from value of asterisk APTR. Okay, one more important thing I would like to mention here is asterisk and %, are complement to each other, are complements of each other. Okay, meaning, so let's see. Okay, if I put % sign here, what is the value which is returned by this?
Seven.
Address of A.
Address of A.
Address of A. Very good. Okay, this will actually return address of A. Address of A. Why? Because asterisk A pointer means 7. Okay, the location where 7 is stored. So this 7. What is the address of this location? The address is the address of A actually. Okay, so this entire thing is nothing but the value of A and address of A. This will reduce to address of A and it will return address of A. Okay, whatever that 002 thing. Now, if I reverse the order, if I say address of APTR and asterisk sign, what it will return?
Address. Address.
Address, right? So now these two things are complement to each other, and this is what you need to understand. So when we print these two values, okay, the address of A will get printed. Making sense?
Ma'am, if we have to declare a pointer, then is it necessary to use the keyword PTR?
No, it is not necessary. It is not at all necessary, but this is just a good programming practice. That's it. Okay, you can keep it as asterisk, anything like ABC or something. You can even keep it asterisk Y or X, and X is equal to address of A. It will also work. Okay, these are just variable name, and it is true for all variable name. There is no compulsion, but there are some good practices which people will use in a standard manner to make their program more generalized. That's it. Okay, now about the operator precedences. So asterisk and ampersand stands here. Okay, after all the postfix prefix, this postfix plus plus and minus minus brackets operation, it will stand with the prefix operators and all these things. Okay, so all these are having same uh, precedence. All these are unary operators. Okay, and they will work from right to left. Okay, in this manner. They will not go from left to right. They will go from right to left. Any question?
No, ma'am.
Okay. So maybe I will share this program as well. So I have to share the 2D program with you and this particular program. Okay. All right. So let's move. Now, whatever we have seen now, whenever we pass a variable, in the function, that is called pass by value. Okay. Now we can also do a pass by reference while passing the arguments to the function, and that can be done through pointers, right? So there are two ways to pass the argument to a function. Either you can pass by value or you can pass by reference. Okay. By default, all the arguments are passed by value except for arrays. Okay. All the variables we have seen pass by values. But if you want to make use of pass by reference, okay, you want that the function should have the capability to modify the original value of the variable, then you have to pass that pointer. Then you have to pass you have to do pass by reference, and pass by reference can be done using pointers. You have to actually pass the address of that variable. Okay, so whenever any changes will be made at that location, it will actually reflected in the original value. Okay, and why it can be used? So as written in the slide, then that when we are having very large data objects, okay, it is a overhead to pass the entire object, because when we do a pass by value operation, one more copy of that object has been created. Okay, the local copy to the function. So the entire copy has been made. If the data type is too large, then it will take too much time. Okay, and at that time there are requirement that the function should do the modification in the original value without making any other copy of the object. Okay, so we can use pointers and the indirection operators to do pass by reference. Okay, so what you have to do is this: when we call a function, in the arguments, what we will pass the address of the argument. Okay, and how we can pass the address of the argument? We can do it using %. Okay, so if you want to pass a in the function, okay, so suppose there is a function square and I want to calculate the square of the function, or I want to change the value of that particular variable a, and I would like to make it 10 from 5. Okay, so what I will pass? I will pass address of a to the variable. Okay, and when we define the square function, we will make an object of pointer type. So maybe aptr, because aptr now is capable to take address of any object. Okay, so this is how we will do. So we will just see how we can do it in the example. Okay, all right. So arrays are not passed using address operator, because C automatically pass the starting location of the memory, right? So this is actually equivalent to, the name is actually equivalent to address of the first location. So there is no need to give % sign again, right? Now when the address of the variable is passed to a function, the indirection operator, asterisk operator may be used to modify the value stored at that location, because asterisk will give me the value of the object which the operand is pointing to. Okay, so now we will see a cube function. In one we will do call by value, and in one we will do call by reference, right? So let's have a look at the function. Right, so this is the prototype. Okay, so cube by value. In cube by value we will have a simple variable, right? So what we will do actually, so we are having a number 5. The original value of the number is 5. Okay, so 5 will get printed. Then we will call our cube by value function and store that value here in the number, and then again we will print the new value. right? And here we just pass the number, and in number what we will return, n into n into n. Okay, so if the value is 5, the initial value is 5, right? The function will call, and here the value of number will become 125. Okay, this will get printed. Okay, so this is a normal operation that we have seen. Now let's say how we can do it using pass by reference. Okay, yes, so this is cube function by reference. Here please note that instead of giving a simple variable, you have to mention a pointer type variable. Okay, so this is an n pointer pointing to integer type object. Again, we will initialize the number. The original value is still 5. Okay, now here what we are doing is this. So in the previous example, if you notice, we are actually updating the number in our main function. We are updating the number, okay, because cube by value will not update this number. But in this function, we are not updating. We are just calling cube by reference function, and we are passing the address of number. Okay, so number is a variable. 5 is stored at this location, and some address is there. Okay, so let me just write it something like this. So this address will get passed. Okay, now we are having another variable nptr. Okay, now this variable is actually pointing to this location. Now when we perform operation on nptr, so see what will happen. Asterisk nptr is equal to, okay, so this is the operation we will perform. Now what is this operation? This will give the value 5. This will also give the value 5. This will also give the value 5. Okay, 5 into 5 into 5, it will give us 125, and nptr is equal to 125. Now what this will do, the value stored at the the object which is pointing by the operand nptr, store 125 there. Okay, so this is what it is doing. So at nptr, it will actually change the value here. It will actually change the original value, and hence when we print number again, we will get 125 as an output. However, we have not changed the number inside the main function anymore. Okay, so the output will be this. This is called pass by reference. Yes, I am open for questions. Any question? What you have to remember, just remember two things. First thing is, when calling a function by reference, you have to pass the address of the variable, not just the simple variable. This is the first difference. In pass by value, we just pass number, but when we are doing call by reference, we are passing address of that number variable. Second difference is, when we are in the definition, actually in the when we are defining the function, instead of giving a normal variable, you have to make a pointer type variable, because we are passing address from there. Okay, so this variable should be of pointer type, otherwise you will get error. Okay, and why we are doing call by reference, you already know that it will actually make changes in the original value, so there is no need of doing any modification in the original value. Now cube by reference function is capable of modifying the variable which is defined inside main function.
Ma'am?